Hi everyone. So today we are going to discuss about fractions, which is very much interesting one. So most of them might be aware of these fractions, but let's see straight away into the introduction of fractions. So fractions. In this video, we are going to discuss about introduction of fractions, types of fractions, okay, and the properties of fractions. So fractions. What exactly a fraction? So when you heard the word fraction, okay, so fractions represent the part of a whole or collection of objects. So if I say, for example, your friends are sharing a pizza, right? Pizza slices. So the pizza slice is divided into, let us suppose, 6 pieces. So you took 2 pieces out of 6 pieces. You took 2 pieces. So the part you took, the from the whole 6 parts, you took 2 parts, right? So that's why from the part of whole, I mean the 6 parts, you took only 2 parts. So that's what the fraction is, nothing but the part of a whole or collection of objects. So a fraction will have 2 parts. The fraction will have 2 parts. One is numerator and the other is denominator. One is numerator and the other is denominator. So what exactly this fraction means? So it contains 2 parts, as we have seen this. The fractional part, the top of a line which is represented in a fraction, we call it as numerator, and the below part, the number which is below the line, we call it as denominator. Okay. So what is this numerator and what is this denominator? As I mentioned the example of pizza slice, as you took 2 pieces out of 6. So the 2 parts which you took, the part out of the whole 6 parts, the part which you took, okay, that is 2, right? So that part is nothing but numerator. And whereas the total parts, always the total number of parts which are divided, that one will be in the denominator. Okay. So in this particular example of pizza slice, the 2 parts which you consumed or which you took, that is nothing but the numerator part which is on the top of a line, and the below part which is there, the total parts representing, that is nothing but denominator. Okay, because whenever you're writing a fractional part, the parts which are divided in a fraction should be always equal. That's what we mention it as equal parts of the whole. Equal parts of the whole. So that part which you took out of the whole 6 parts, that is numerator, and then the denominator, the below one, that is the total parts, total equal parts, that is nothing but denominator. Okay. So let's see in detail with the diagrammatic one about fractions. If you look at this example, a cake, like as I mentioned the example of a pizza slice, here they mentioned a cake. A cake is divided into 8 equal pieces. Okay, you can see that in the diagram, 8 equal pieces. So the 8 equal pieces are in such a way that one piece of cake is placed on a plate. So totally 8 plates, 8 pieces. So each piece is nothing but 1 by 8, because as the cake is divided into 8 equal parts, the total parts are always in the denominator, and the piece which is in each plate is 1. That's why the fraction is 1 by 8 here. So we'll read it as 1 by 8 or 1/8. 1 by 8 or 1/8. Okay. So the fractional part which is in the each plate, okay, there is only one piece, but we read this as 1 by 8 or 1/8. Okay. So each plate will be getting 1 by 8 of the cake. So 1 is nothing but numerator and 8 is nothing but denominator. Okay. So 1 is nothing but numerator and 8 is nothing but denominator. Okay. So from this example, it's very clear that the fraction is always in a way that from the part of a whole, right? So the part of a whole means the total number of equal parts which are divided, that will be in the denominator, and the parts which are consumed or which are shaded, something like that, will be in the numerator. Okay. So over here in this example, that 1 by 8, one piece of a cake in each plate, that 1 is nothing but numerator, and the total equal parts 8 is in the denominator. Clear? So now let's see with another example. So if you want to represent a fraction from a diagram, if you look at this diagram, so we have two circles, right? One circle is having equal parts, right? This circle is divided into 4 equal parts. And if you look at the other circle, it's not divided. Of course, it's divided into 4 parts, but they are not equal. That's why the definition of fraction also is given clearly. The total parts which are divided should be always equal. That's what they mentioned, equal parts, right? Okay, according to the definition, they mentioned clearly that should be divided into equal parts. It can be 4 equal parts, 5 equal parts, 6 equal parts, as many number of parts, but that should be divided equally. So in this first example, we can represent in a fraction. How? Over here they shaded 3 blocks. Over here they shaded 3 blocks. So 3 blocks means the shaded part fraction is nothing but 3 by 4. 3 by 4, because the 3 parts are shaded out of total 4 equal parts. Whereas in the second one, we can't write it as 3 by 4 because they're not divided equally, right? Always the fraction has to be represented in such a way that all the parts in a diagram should be divided equally. Okay, not just a diagram, it can be any particular thing. Okay, it should be always divided equally. If it's not equally divided, we can't represent it in the form of a fraction. Okay, now let's discuss types of fractions. Okay, so over here, based on the numerator denominator, we have different kinds of fractions. If you look at this particular table regarding the types of fractions, the first one is unit fraction. The name itself specifies unit fraction means the numerator should be 1. The numerator part of unit fraction should be 1. So that's why the example is 1 by 7. Now coming to the next one, proper fraction. In a proper fraction, always the numerator should be greater than denominator. Numerator is less than denominator. So in proper fraction, numerator is less than denominator. That's why if you look at this example, the numerator value is 2. 2 less than 7. Whereas in improper fraction, the one which I told, the improper fraction will have numerator greater than denominator. Okay, numerator is greater than denominator. One of the example they give it as 5 by 3. Okay, numerator can be greater than or greater than the denominator part. Now coming to mixed fraction. The mixed fraction is always a combination of a whole number and a proper fraction. Mixed fraction is a combination of a whole number and a proper fraction. Like if you look at this, 8 2 by 3. So 8 is nothing but a whole number and 2 by 3 is a proper fraction. Okay, always a mixed fraction contains a whole number as well as a proper fraction. Now coming to the next one, like fractions. If the fractions are having same denominators, we call them as like fractions. If you look at this example, 1 by 4, 3 by 4, both the fractions have same denominators, right? 1 by 4, 3 by 4, both the fractions have same denominators, so they are called as like fractions. When it comes to unlike fractions, it's quite opposite. If the denominators are different, they are known as unlike fractions. If the denominators are different, they are called as unlike fractions. Okay, fractions with different denominators like 3 by 5. Okay, here they give same denominators, but if they are having different denominators, we call them as unlike fractions. Equivalent fractions. Equivalent, the name itself specifies whenever they mention equivalent, both the fractions, if I simplify to its simplest terms, as we discussed in ratios about simplest terms, right? So when I simplify a fraction to simplest terms, both will be same. Like 6 by 4. If I simplify, what do I get? 6 by 4, 2 3s, 2 2s, 3 by 2. Same thing happens for 12 by 8, 4 3s, 4 2s. So if I convert any particular fraction to simplest terms, I'll be getting it as same value. That's what, even if I simplify 6 by 4, I got 3 by 2. Even if I simplify 12 by 8, also we got 3 by 2. Okay. So the most important one, this tabular form is very, very important. because if you know clearly what a kind of a fraction, like fractions, unlike fractions, equivalent fraction, unit fraction, mixed fraction, then it will be very much useful for to do the problems. Okay, let's see the next one. What exactly a mixed fraction and what is this? How to simplify the mixed fraction? We'll see a concept regarding that. So in mixed fractions to improper fraction, as we discussed, mixed fractions are nothing but a combination of a whole number and a proper fraction. Okay, a combination of a whole number and a proper fraction. Here we can see the example 5 2 by 3. So what do we do when a mixed fraction is given? So first we'll multiply this 5 and 3. That's what 5 into 3 plus 2. Okay, first we'll multiply 5 into 3. 5 3 is 15 plus 2 becomes 17 by 3. Okay, so whenever you want to convert a mixed fraction to improper fraction, first multiply these two terms 5 and 3, and then we'll add the above one. The denominator part and the whole number part will be multiplied and the answer will be added to numerator, so that we'll get an improper fraction. So from this video, I discussed all the types of fractions, the introduction of fractions, and what is the simplification we do for a mixed fraction and all. Okay, so please try to check this introduction of fractions carefully, because this fractions is followed by operations of fractions. Because if you understand this introduction of fractions clearly, then the operations on fractions becomes quite easier. So please try to focus on this video and please try to like, share and subscribe to our channel to get more and more interesting videos. Okay, thank you everyone.